Chapter 8.2 exercises 52 through 56. This section 8.2 in our book has to do with ellipses, and these exercises have to do with celestial bodies. And we're going to do these odd number problems in this set, which are going to be 53 and 55. In this one, 53, the moon's orbit. The moon's apogee, farthest distance from Earth, is 252,710 miles, and perigee, closest distance to Earth, is 221,463 miles. Assuming the moon's orbit of Earth is elliptical with Earth at one focus, calculate and interpret A, B, C, and E. Well, let's just go ahead and make a list of what A, B, and C, and E are. Well, A is equal to, we call our semi-major axis. So we find our largest axis and divide that by 2. We have our semi-major axis. B is, logically, what is it going to be? It's going to be our semi-minor axis. And if we find what the minor axis is, we divide that minor axis by 2, we get our semi-minor axis. C is our focus distance from center of our ellipse. And then the last thing we have here is E, which stands for eccentricity. Now, you might notice in eccentricity this CENT, which has to do with center. So a literal interpretation of eccentricity is off-centeredness. And so there's a formula we're going to use to determine what that eccentricity is. But the first thing we're going to look at is a sketch of what we are given. We're given the Earth right here, we'll call E, and we have the moon a certain distance away. Okay, that's our moon away on one side and on the other side. And to the right, we're talking about the farthest distance away, or the apogee, is going to be 252,710 miles. And our perigee, which is our closest distance, is going to be 221,463 miles. And our major axis is going to be the sum of the apogee and the perigee. Now we're assuming that the focus is going to be where the Earth is. The Earth is at one focus. So here's our focus right here. And C is going to be how far this focused Earth is between the center of the moon to the right and our moon to the left. So let's go to our calculator and add these up. So we have 252,710 plus we have 221,463. And so this number, 474,173 miles, that is our major axis. And our semi-major axis is this number here divided by 2. And so that's going to be, let's go to control estimation here. Well, divided twice. Let me go ahead and multiply that by 2. I don't know what happened here. There we go. So 237,087 miles. So 237,087 miles. So A equals 237,087 miles. Okay, and C is going to be our difference, is going to be this number here, and we can just take any one of them. We'll take 252,710 miles, and we subtract out this 237,087 miles. We're going to get our value of C, our distance of our focus. So let's go back to our calculator, and we put in 252,710 minus, we're going to take, what was that? I think it's going to be this 237,087. So 237,087. So this is going to be our value for C, which is kind of how far from the center of the ellipse is the focus. So 15,623 miles. Okay, so those are two answers. Now to find what B is, our semi-minor axis, well, we have the formula C squared, our focus formula, equals A squared minus B squared. So we have C squared, which is going to be 15,623 squared, equals A squared, which is 237,087 squared, minus B squared. So if we add B squared to both sides of the equation and subtract C squared, we're going to get B squared. B squared is equal to 237,087 squared minus 15,623 squared. And so we're going to go to our calculator and get what that is. In fact, let's just go ahead and get what B is. B is going to be equal to the square root of all this, isn't it? So we take square root of 237,087 squared minus 15,623 squared. So we'll just make this one calculation. So going back to our calculator, we have the square root of 237,087 squared minus 15,623 squared. And so we're going to have our, this is it, 236,572. 236,572 miles. $236,572 miles. And the last thing we're going to calculate is our eccentricity, which we're going to get by taking E is equal to C over A, which is going to be this 15,623 over A, which is 237,087. Okay, and going to our calculator, we get 15,623, and we're dividing that by 237,087. And so we get eccentricity of 0.0659. So I'll put 0.0659, round to the nearest 10,000th place. Point 0.0659. So there we have our eccentricity here at the bottom. We have our semi-minor axis B. We have our C, which is our focus distance from the center of the ellipse. And then we have our semi-major axis, which is 237,087 miles. So next, let's go on to our next on problem 55. Saturn. Find the perihelion and aphelion distances of Saturn. And we're given a semi-major axis in GM, which is gigameters, and we're given an eccentricity. And so what we have to find out our perihelion and aphelion distance, we need to find our focus distance. Well, what we have is our eccentricity is equal to our focus over our semi-major axis. Well, in this case, we're trying to find really what the we're trying to find what the focus is. So if we multiply by A, C is going to be equal to our eccentricity times our semi-major axis. So let's find out what that is. And that's going to be C is equal to, in Saturn, that's going to be 0.056, which is E, times A, and A is going to be 1,427. That's going to be gigameters. So we go here. We have 0.056 times, we have 1,427 gigameters. And so that's going to be at 79.9, which we'll call this 80 gigameters. So we'll say that C equals 80 gigameters. And so what it is, our perihelion, and our perihelion is going to be our closest distance, and that's going to be, that's going to be 1,427 minus 80. So I will say perihelion equals 1,427 miles minus our gigameters minus 80, and that's going to be equal to, I think, 1,347 gigameters. Okay, and our aphelion, which is our longest distance, is going to be this semi-major axis, this time plus 80 gigameters, which is going to be equal to 1,507 gigameters. And so there we have our perihelion and aphelion together here, and we have that. So these are some interesting problems, some real world, I won't say real world uses. How about real solar system uses? 56, finding equations for orbits of Venus and Mars. 54, finding how close Mercury gets to the sun's surface. Problem 52, proving the planet the most eccentric orbit, sometimes closer to the sun. I think that's going to be our most eccentric orbited planet is going to be this Pluto. So Pluto probably will be closer to the sun than Neptune on occasion. So this is a good little set. Good luck on the rest of the problems here, and thanks for viewing.